The mesh menu item, toEdge, is to generate a two-dimensional mesh based on two boundary lines. Let's make a simple example. First, create two separate curves, each one of which is a boundary line. The number of nodes on both of the boundary curves should be identical. Select the two curves at once, by using rubber band. Choose Divide 20, item from Divide menu. Each curve is divided into 20 segments. Thus, 21 nodes are created on each curve. Select the item Two Edges from Mesh menu. Then, Two-Edge Mesh dialog pops up. The element type is set to Tria3, which means 3-node triangular element. The triangular arrangement is set to Optimal, which means triangles are formed for optimal shape. Let's change the division from 6 to 10. Thus, the gap between two boundary lines will be filled with 10 lines of elements. It is called lofting mesh generation. In order to compare the other options of triangle arrangement, undo the mesh generation. And change the option to Union Jack. Regenerate the mesh. It shows the triangle arrangement of Union Jack. Let's try another option, left. The triangles are arranged by diagonal lines from left top to right bottom. Now, let's change the option of element type. Click Quad 4. This option generates 4-node quadrilateral elements. Element type option, Quad 8, is for 8-node quadrilateral elements. In order to check the quadrilateral elements with 8 nodes, choose Node Selection tool. Select the nodes by a rubber band. This shows that each element consists of 8 nodes. The next example of two-edge mesh generation is to show multiple composition of boundary lines, and weighted spacing of elements. One boundary line is a circular arc, and the other is composed of two straight lines. The circular arc is divided into 20 segments, and each of the straight lines into 10 segments. Thus, both boundary lines are composed of 20 segments. Two-edge mesh dialog again. The element type is 4-node quadrilateral. The division is set to 12. Select the boundary lines. Generate the mesh. The gap between the boundary lines is now filled with 4-node quadrilateral elements, with uniform spacing. Alternatively, the mesh can be generated with non-uniform spacing. Let's change the spacing weight to 1 versus 3. The mesh is generated with gradually varying lofting length from 1 to 3 ratio as indicated on the screen. Another example of two-edge mesh generation is the case in which each of the boundary lines is closed by itself. In order to reduce the time, this demo will use boundary lines prepared in advance. Let's first check the division of each curve forming the boundary lines. Double-click one of the curves. Then, the Curve Info dialog pops up. The dialog has information about the selected curve, including the number of divisions. It shows that the curve is divided into 10 segments. Move the screen cursor over other curve. Then, the curve is highlighted and the dialog shows the number of division as 8. Next one is 10, and 10, and 10, and 4, and 4, and 20. We confirm that each of the inner and outer boundary lines have identically 38 segments in total. So, the boundary lines are compatible for two-edge mesh generation. After closing the Curve Info dialog, let's go back to the two-edge mesh dialog. Set the division to 8, the weight to 1 versus 2, and the element type to Quad 4. Generate mesh. Then, 4-node quadrilateral elements fill the gap between the boundary lines. The nodes are matched between the inner and outer boundary lines automatically. However, this automatic matching may not be desirable. In such a case, use the left or right shifting button. Click the left shifting button. Then, the matching is shifted in left direction. Clicking the right shift button will reverse the shifting to right direction. In this way, we may obtain the best matching manually. This is the end of the tutorial for two-edge mesh generation.